Hello friends, welcome back. I hope you are doing fine. And this is the 8th session in the electrical and electronics engineering interview questions. I hope you have been enjoying the series and thank you very much for the encouragement. We'll go to the questions right away. When Kirchhoff's voltage law can be validated? Simple, it can be validated only in a closed loop. Please understand, Kirchhoff's voltage law KVL can be validated only in the closed loop. What is Kirchhoff's current law? It's a very simple question, yet a very important question. In a node, the sum of the incoming current equals the sum of the outgoing currents. Sum of the incoming currents is equal to the sum of the outgoing currents. It means no current can get accumulated at any point in the circuit. No current can stay there. Whatever is coming in must go out. So that's what is Kirchhoff's current law. What is meant by a junction, branch, node? It's a very important question. What do you mean by a junction, branch or a node? A junction is a point where minimum of 3 circuit pathways meet. This is like your railway junction in India. You can see that we call some particular station a junction where 3 points will meet. It will connect to 3 different places. So a junction is a point where minimum of 3 circuit pathways meet. A branch is known as a pathway that connects 2 junctions. Please understand, a branch is which connects 2 junctions. A junction where 2 or more circuits elements meet is called a node. Remember, these 3 are very important definitions. You can also call a node is a point of connection between 2 or more branches. So to make it simplified, a node is a point of connection between 2 or more branches. Remember, junction is where you have minimum 3 circuit pathways meet. A branch is where you have got 2 junctions connected. A junction where 2 or more circuits elements meet is called a node, and this is a very important question. Can a transformer be used with a DC? This is the next question that we need to answer. Now take the principle of mutual induction. The principle of mutual induction, in which the current flowing in one coil or winding, when current flows in one coil or winding, it naturally induces voltage in another coil, and this principle holds good in case of a transformer. So the transformer fundamentally is connected to this principle. So if a DC supply is given, the current remains constant, right? Since the current in one coil does not change with time, no EMF will be induced at all. This is a major point. Since the current in one coil is not changing with time, EMF will not get generated, EMF will not get induced, so the transformer will not work. That's the fundamental principle. Now the next question is going to be closely aligned to the first one. What will actually happen when a DC voltage is applied to a transformer primary? Can we notice any output at the secondary windings? Can we do that is the question that we are trying to ask. So on applying the DC voltage to the primary winding of a transformer, there are some things which could happen which is not acceptable, which is not advisable. The windings or coils offer low resistance. This is the general point. The windings or coils generally offer the low resistance, and they act as a short circuit which will lead to heavy flow of current through windings. So what will happen? There will be a heavy flow because there is a short circuit component that we discussed. As a consequence, as a result of this, definitely there could be overheating or burning out of the primary winding which occurs, and this could eventually damage. So there won't be any output in the secondary winding except for a sudden spike that may be noted down initially due to the sudden surge of the current at the onset and nothing else later. So this is not a right approach, and this will actually cause damage to the winding is what the point we need to understand. Thank you very much for following the channel and the content. If you have any questions, please post it across. We'll be very happy to answer. If you have any comments, please let us know. We will improve ourselves. And if you like the channel, kindly subscribe. Thank you.